All right, so going through the first one, we said we're going to use the ratio test, right?
Yes.
Yeah, so you need to explain what test you're going to use beforehand. So you say by
Oh,
the ratio test.
okay.
Okay. You even say what the ratio test says. What is expected from the ratio test? Okay. Uh,
Okay.
what does the ratio test test? If you take the of the absolute value of a.
Okay, so if
Mm-hmm,
mhm,
mm-hmm,
mhm. Okay,
over.
so the limit if the limit is less than one, it will converge. If it's
Mm-hmm,
if it's greater than one or infinity, it will diverge.
mm-hmm.
And if it is one, it will be inconclusive.
Okay. So you state that so that we know what you're doing. Okay. That's when now you
Okay.
start your test. So now in our case, we have so for all the questions, this is the same outline I want you to be taking.
Okay.
So we have 2 to the power n over n factorial. Uh, then what is our an in this case? An is equals to,
Our AN is the same, which has been given, which is 2 to the n over n factorial.
okay, and what is our an plus 1?
Our AN plus 1 will be 2 to the n plus 1
Mm-hmm.
over n plus 1 in the brackets factorial.
Okay. So now we apply now. We apply limit as n approaches infinity. You put you're starting with your n plus 1, right? Okay, so you put 2 to the power n times 2 all over n plus 1. There's just one where then this will be the inverse of this, which is n factorial over 2 to the power n. Okay. Now I want you to tell me how you approached this factorial here.
The factorial at the bottom.
Mm-hmm.
Okay, so I said what's inside the brackets will remain the same, n plus 1, and then there will be n outside factorial.
Oh, okay. Yeah. So basically that is correct. I just didn't see it properly. So this will cancel and this will cancel. We have 2. We know that this is n plus 1 times n factorial. This is coming from the fact that n factorial is equals to n minus 1, n minus 2, and so on and so forth, right?
Yes.
Yeah. Okay. All right. I wasn't seeing that properly. So that's what I wanted to confirm. So this
Oh, okay.
factorial and this will go, and we'll remain with the limit as n approaches infinity of 2. I'll add something here. You
Okay.
can also determine the, okay, of 2, where is 2 all over n plus 1. Okay. Then when you take this limit, we know that this approaches 0, right? As n approaches infinity.
Yes.
Yeah. Okay, so we conclude that it diverges, right? Or it converges.
Yes. Yes.
Yeah, so that's basically it. Now you can be asked. You know that you can find the radius of convergence using the ratio test.
Okay.
Okay, when you just reach this part here, the radius of convergence is actually the inverse, limit as n approaches infinity of an over an plus 1. So that is the radius of convergence. You take the inverse. So here, this is the same thing as limit as n approaches infinity of n plus 1 modulus all over 2. So in this case, the radius of convergence is what? When you take the limit of n plus 1 over 2?
The radius of convergence would be 1.
How 1? There is 2 here. When you take the limit of this, n plus 1 over 2.
Let me look at it.
Infinity plus 1 over 2. What would be the answer?
I'll say that again.
You can see my screen, right?
It has gone. Okay, it's
Yeah.
back. It's back.
Yeah. So infinity plus 1 over 2. What are you getting?
That's infinity.
Yeah. So that's the radius of convergence.
Okay.
Yeah. So basically, you can use the ratio test and the root test to find the radius of convergence as well. Yeah, so in case the question says test the convergence, and if it converges, find the radius of convergence. You just take the inverse of the root test or the inverse of the ratio test. So for the inverse of the root test, you just take the limit. Okay, I'll just put it as an over an plus 1 over 1. So the inverse of that will give you, you just flip. Same applies here as n approaches infinity of 1 over the modulus of an to the 1 over n. So these can also help you find the radius of convergence if a series converges. Yeah. So that is just my additional point. So you can finish the other
Okay.
ones, then you would send
Okay.
them as soon as before what time? What time am I going to expect?
Um, just give me a